All right, so today we're going to talk about calculating with sig figs. But before we get started, just to review, the way that you determine the number of sig figs that a number has, let's say I have the number 340. I want to use the Atlantic Pacific rule if this is the United States. I have the Atlantic Ocean on the right and the Pacific Ocean on the left. P stands for if the decimal point is present. A stands for if the decimal point is absent. And what you're going to do is start counting from the first non-zero number. So in this number we have a decimal point absent. So we're going to draw a line through the 0. We're going to start counting at the 4 because the 4 is the first non-zero number. So we have 2 numbers and then we count all the way to the end of the number. So we have 2 significant figures in this number. If we had a decimal point present, like 340 with a decimal, now we're going to count from the Pacific side, or the left side, and we're going to count all the way to the right. This number has 3 sig figs. Even though it's the same value, this number is more precise or more accurate. We are closer, or we have more information about the number. This could be any number between 335 to 344 if we had to round to the hundreds place. Whereas in this number, we know that the value is 340. What we're not sure about is the number that comes after the decimal place. So this number is more accurate than the number without the decimal place. More precise, okay? So when we talk about calculations with sig figs, there's 2 main rules. There's the multiplication and division rule and the addition and subtraction rule. So when you multiply and divide, your answer will have the same number of sig figs. SF is short for sig figs, as the number that has the least number of sig figs. So that can be kind of confusing. For example, if I'm going to do 3.0 times 5, okay, 3.0 has, we've got a decimal place, so we're going to start counting from the Pacific, 1, 2. We've got 2 sig figs here, and this is pretty clearly just 1 sig fig. So our answer can only have 1 sig fig, okay? We're going to use the number that has the least number of sig figs. So our answer can only have 1 sig fig. So our answer is going to be, oh, we have 15. Well, that's 2 significant figures. So at this point, we have to round to 1 sig fig. So we're going to start at the left. We're allowed to keep this position, this significant figure. This number is going to have to be rounded away. It has to turn into a 0. So 5 tells me that the 1 is going to round up. So 20 with no decimal point. So again, decimal point's absent. I'm just going to check and make sure I have the right sig figs. 2 is the only significant figure. So now I have 1 sig fig and my answer is 20. Now you might be thinking, well, 15 and 20 are 2 totally different answers, but that's the point. The reason we use sig figs is so that when we have uncertain measurements and more certain measurements, we do not over indicate how certain we are about our answer. So this is the correct answer. It can be kind of tricky. So let's come up with another example. If we do 20.0 divided by 4.0, this number has 3 sig figs This number has 2 sig figs. So 20 divided by 4, we know that to be 5. But when we're talking about measurements, we need to use our sig figs. So our answer can only have 2 sig figs. This is the smaller number of sig figs. So 20.0 divided by 4, it's going to be 5.0. The 0.0 gives us that extra significant figure to indicate that it is exactly 5. Okay? So then we can talk about addition and subtraction. With addition and subtraction, your answer will have the same number of decimal places as the number that has the least decimal places. So, for example, if I'm going to add 150.1 plus 10.32. Now, if I add that, normally what I would do is I would go ahead and I would put a 0 here, but we can't add a 0 there. We are not certain enough about this answer. So I know 0 plus 2 is 2. 3 plus 1 is 4. 0 plus 0 is 0. 5 and 1 is 6 plus 1. So if I were going to just plug this into a calculator, this is what my answer would be, 160.42. But using sig figs, I have to use the same number of decimal places as the number that has the least. So I'm only allowed 1 decimal place in my answer. So even though this is what I would get out of a calculator, the correct answer with sig figs is going to be 160.4. Another example. Let's say I have 150.1 minus 30. Now this number does not have a decimal, so I'm going to actually add one here. So I know normally 1 minus 0 is 1. 0 minus 0 is 0. 5 minus 3 is 2. And 1 minus 0 is 1. So my answer out of a calculator would be 120.1. But in this answer, my second value here does not have a decimal in the tenths place. So my answer can only go to the ones. So I'm actually going to have to get rid of this value. So my answer is going to be 120 with a decimal. Now the reason that I need the decimal here is so that it shows that I know it's 120. This is not the same as this. This number has 3 sig figs. This number has 2. The decimal gives us more information about how accurate that number is, how precise that number is. So now we're going to talk a little bit about scientific notation, and we're going to do a little bit more of the math. But scientific notation helps us with really, really big and really, really small numbers. So large numbers, such as the speed of light, help us indicate the largeness of those numbers without having to write out all those zeros. So you're going to take the number, such as here we've got the 300 million. Your decimal goes after the first non-zero. So that's anything that's not a 0. 3.0. So in every scientific notation number, you'll have a non-zero, and sometimes you'll also have a decimal. Okay? Only significant figures are reflected here. And then we're going to multiply that number times 10, and we're going to raise that 10 to an exponent. In this case, we're going to put to the 8th. Now, why is it the 8th? Normally, the decimal point would be over here, but we've now moved it. 1, 2, 3, 4, 5, 6, 7, 8 places. Okay, so if I'm going to take this number and put it back into regular notation, I'm going to move it to the right. Positive numbers, decimal moves right. That's to get out of scientific notation. So then, it's the opposite for smaller numbers. If we have one atom of carbon and it weighs 0.00000, all those zeros, it doesn't make sense for us to write that. So we are going to move that decimal over 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, all the way over 23 places. So that's where this number comes in. So we end up with a decimal after the first non-zero. So we stick it right in there, and then we multiply the non-zero numbers times 10 and raise it to the number of decimal places that we're going to move. Now, in the last slide and in this slide, you'll see this here. Okay, this is how you're going to put it into your calculator, and we're going to talk about this in class so that I can help everybody with their own calculations and their own calculators. So here are the rules, just in case you didn't catch them. Any number 1 through 9 appears to the left of the decimal. Okay, all other significant numbers appear to the right of the decimal. So you're going to have some non-zero number like 1.99, and then all of your other significant figures will come after the decimal. So let's put some of these numbers in scientific notation and make sure they match up. We've got 1, 2, 3 with a couple of zeros after it. So the decimal right now is kind of invisible, but it would be here. So we're going to move it over. 1, 2, 3, 4, 5, 6, 7, 8. So we're going to put 1.23 times 10 to the 8th because it's a big number. Big numbers have positive exponents. Decimals, or small numbers, have negative exponents. We're going to move this one over 1, 2, 3, 4, 5 places. So this time we get 1.23 times 10 to the negative 5th. This number, we're going to only move the decimal over 1, 2. So we get 5.962 times 10 to the 2nd. And this one, we're going to move over 1, 2, 3, 2.3. This 0 gets to stay because it's after the decimal, it's significant, times 10 to the negative 3rd. So we know this number has 3 significant figures. We could check that out by doing our Atlantic Pacific rule, 1, 2, 3. So all 3 of those sig figs get to go in the number. So at this point, we're going to cut off, and we'll talk a little bit more in class about scientific notation and significant figures. We'll get a little bit of in-class practice, and hopefully this was helpful for you. Just make sure that you took your notes for the video, and I will be checking those in class. Thanks.